All right, hi guys. So guess what? We're going to figure out networking servers. Yeah. So what does that mean? Well, a network server is a computer, right? And it's designed to act as a central repository and help provide various resources like hardware access, disk space, printer access, all these kinds of things to other computers in that network. So a network server might not differ from a workstation in its hardware, but the functionality it performs clearly differentiates it from other workstations. Network servers help in simplifying the different tasks for system administrators, including those centering around management. So any configuration or security update can be applied to a network server instead of individually passing to different computers connected to the network. Now, there are a few factors that influence the choice of utilizing network servers. You first want to consider the number of users in the network, the classification of the network used, business growth plans, if any. There are lots of features with network servers. These computers are provided with more memory and storage capacity. They're also configured to do additional processing to handle the different client requests, all simultaneously. Machines are usually high-performing personal computers with reliable and fast hard disks, powerful processors, as well as high amounts of available RAM. Now, they can also act as a central file storage unit. So this can prevent data being stored in different workstations around the network. Authentication and user control can be set on another workstation using a network server. Security control measures can be way more convenient to manage using a network server. Also network servers are capable of running an intranet. Some of the more common examples of network servers are DHCP servers and DNS servers. You see, actually, DHCP and DNS are two essential services in IT networks. So while a DHCP server sends out information the clients need to communicate with other machines and services, DNS ensures that servers, clients, and services can all be found by their names. So let's talk about that a little bit more. Dynamic Host Configuration Protocol, DHCP. So it dynamically assigns IP addresses, as well as other configuration options to devices in a network. So this way it's very easy to add new computers or tablets, smartphones, whatever you got, bring it on, right? Administrators no longer have to configure every single device manually, since the DHCP server does this job automatically. So this is why DHCP is great for larger networks with continually changing clients, for example, schools and different companies, as well as small businesses, etc. So the DHCP server either distributes free IP addresses from a specific pool, or it assigns static addresses to the clients and then identifies them via their MAC address, which is the Media Access Control. It's a unique identifier assigned to a network interface controller. So in the first scenario, the clients can get different IPs, which can be convenient if the server hands out addresses from a small pool to a large number of devices that are not always active at the same time. If the DHCP server distributes static addresses, all clients always receive the same IP, ideal for network services or certain machines that have to be accessible around the clock. The DHCP server also determines how long an IP address is valid. If the so-called lease time expires while the client is still active, it tries to automatically renew the lease time. Users don't normally notice this exchange between the server and the client. Now, like I said, the DHCP server can also transfer other information to the client, such as subnet mask, name server, domain name, and gateway, even details for network booting. Yeah, for example, PXE-boot, which is Pre-Boot Execution Environment, NTP, Network Time Protocol, or even proxy configuration via WPAD, which is Web Proxy Auto Discovery Protocol. Now, a unique feature of IPv6 is the Stateless Address Configuration, or SLAAC. So these clients can pick their own addresses based on the prefix being advertised on the connected network interface. A DHCP server can still be useful on IPv6 networks, as it can hand out information about the time server, domain names, DNS servers, etc. to clients. So now what about DNS? Well, it's thanks to DNS, nobody has to remember IP addresses. The domain name system is a hierarchical and decentralized naming system for computers, services, etc., connected to the internet or a private network. DNS works a bit like a telephone book. It assigns domain names like www.google.com to numerical IP addresses, 8.8.8.8, and vice versa. So DNS consists of thousands of servers working together. So if one server cannot resolve a name or IP, well, it can contact another server that can then ask the next one, and so on. A DNS server in a private network, though, is also responsible for the name resolution. It actually knows all the IP addresses and names of the devices on the network. For external queries, that would be out to the internet, the local name server can contact one or more external DNS servers. So here, let's go over some of the differences here, summarized in this table. It's a great little chart here, huh? So here are some of the purposes and the advantages of DHCP and DNS all together. So what did we say that they were called? Dynamic Host Configuration Protocol, and DNS is the domain name system. Now, DHCP runs on port 67 and 68, whereas DNS runs on port 53. DHCP supports UDP, and DNS supports UDP as well as TCP. The purpose of DHCP? Providing IP addresses for a limited amount of time. Assigning IP addresses to the host and configuring hosts mechanically. The purpose of DNS? Resolving domains and translating domain names to IP addresses, as well as translating IP addresses to domain names. And locating Active Directory domain servers. DHCP runs on a centralized system. DNS, however, is decentralized. DHCP is a reliable method of configuring and assigning IP addresses. And of course, the advantage to DNS is preventing users from having to remember IP addresses themselves. So DHCP works by leasing IP addresses and IP information to network clients for a specific period of time. To be able to achieve this, the DHCP client has to interact with DHCP servers through a series of DHCP messages, which mainly include DHCP Discover, DHCP Offer, DHCP Request, and DHCP ACK, like I'm showing you this figure on the screen. Now, hopefully you can see the procedures of how a dynamic IP address is assigned by the DHCP server. DHCP Discovery. The client computer sends out a broadcast packet including its name and MAC address to find a DHCP server. DHCP Offer is where a DHCP server responds to the discovery with an offer for an IP address that's available. And the DHCP server responds to the discovery with an offer for an IP address that is available. And then the client computer then replies with a DHCP request to ask the DHCP server for that IP address that was offered. Then the DHCP server sends a DHCP ACK to tell the client that, hey, it's okay to use that requested IP address assigned to it right now. So simply put, it's just a little story of give and take between the DHCP client, A, and the DHCP server, B. So A says, who can give me an IP address? B is like, let me check. Oh, hey, you know what? I do happen to have one available. A says, great, please give it to me. B says, hey, no problem. Here you are. Or something like that. Anyway, let me show you how DNS works. So check it out. When you're typing in a domain name into a browser, for example, udemy.com, see how the browser often has really no idea where udemy.com is? So it will send a query to the LDNS, which is the local DNS server, asking questions like, what's the IP address of udemy.com? Well, if the LDNS has no record for udemy.com, it's going to search the internet, find out who owns www.udemy.com. But let's break it down so that you can actually see the working details. First, LDNS goes to one of the root servers, which directs it to the .com DNS server. So see, it's the .com DNS server that then finds out the owner of www.udemy.com and notifies the LDNS with a name server, NS record for udemy.com. Then the LDNS responds by requesting an address record, or a record, and this will include the IP address for udemy.com. Then after receiving the A record, the LDNS will send the IP address to the browser and then caches that IP address information for future reference. So to summarize all that, DHCP server assigns the IP addresses to client computers, while DNS server will resolve them. So there are two essential technologies developed for us to be able to use a network and the World Wide Web, quite conveniently. Now, in addition to all that, both DHCP and DNS are essential tools in the Network Administrator's Toolkit for managing all the IP devices on a corporate network. That is up to you. All right, so let's wrap it up here. That's all about networking servers, DHCP and DNS servers, and there will be a quiz. Just not yet. All right, anyway, I'll see you next lesson.